Hello, hello. So welcome to today's Lit Code Challenge. Today I'm going to use this site Code 360 by Coding Ninjas. Before you guys, you should check it out. It has um, very good insights and very good problems, and also it allows you to see the companies that is asking a given question. So, for example, in this question has been asked by Microsoft, Cisco, Bank of America, and Musk. So you should check it out. So today you're going to solve this problem, the fourth largest element in the array. You are given an array consisting of n integers. You have to find the fourth largest element. Okay, so the first largest element, let me go to the sample input. You're given 35131. You should return 1. Why? Because 5 is the largest, then 3 is the second largest, then so this one allows for duplicates, because if 3 is the second largest, then the next 3 is the fourth largest, no, the third largest, sorry, and then 1 now becomes the fourth largest. So we know now they want us to get the first. For example, if you sort the array, the fourth element in the index, if you sort it in descending order. So that could be an approach that we could use. If you're given an array like 35131, you could just sort it out in descending order. So for example, let me write it here. So if you're given this, you could sort it out to this, which will be if you sort it in descending order, it will be 53311, yeah, which could also work. But then this one will take off, sorting takes off n log n, which is not what is expected here. We can improve this a little bit. They want of n, maximum time complexity. Okay, so what can we do about this? And if we are asked most of the questions that require you to return maybe kth largest element in the array, you can use a heap, because a heap has a way of getting, for example, here you want to get the largest element. You can use a min heap. A min heap means that the value at the root node, a heap is more of it's an array, but when defining it can be something like how do we call it, a tree, you see. So for example, what it has is, for example, if we, for a heap data structure is more of a graph or a tree, sorry. So we have 3 here. Well, inserting an element to the heap, for example, the root node is 3. If 5 is greater than 3, then what do? We insert, okay, if you want the minimum element to be the root node, so then 3 will be here, 5 will be here. Then if 1 is greater than 3, then 1 now becomes here, and then this one becomes 3, gets added to that element. So it keeps on maintaining the value at the root node to be the minimum value, minimum number. So you can go and study about the heap. I'm going to implement it here. Okay, so first of all is to use a heap. Using a heap, insertion of a heap is O of log n, which is quite efficient, even more than O of n type complexity. So we can use that one. Okay, so first of all is to check. They have said that if some number is present in an array, then print the minimum value of the integer, which is this. Sorry, I've forgotten to start the timer. Okay, so let me copy it. First of all, we can return this one. We can say int result is equals to this one, this way, this value. And then if the minimum value of the integer, if no such number is present in the array, then print the minimum value. So there are cases where someone can enter n to be 3 or maybe less than 4, which for sure you cannot get the fourth largest element. We have less than 4 elements. So if n is less than 4, then we can just return the result in this case, right? So the next one will be to use now a heap to perform the calculations. So we can import heapq, which is a library for this, and then we can say a heap is equals to, first of all, let's initialize it to be the first 4 elements of the array. Yeah, so in that case it will automatically sort the 4th largest element in the first 4 elements. So I can say I want to take array 0 to array 4, the first element to add array 4. You get it. So, and then for it to become a heap now, a sorted heap, you can just say heapq dot heapify, and then you pass the heap here. So in that case, it will perform those operations, which will take maybe of n log n, sorry. And then the next thing will be now to traverse through the remaining elements in the array and check if the root node, the element of the root node, is less than that element. If it's less than that element, we have now to pop it and push that element. So from element in array, so in this case we can just start from 4, sorry, because you already sorted, you've already added the elements, the first 4 elements in the heap. You can just start with the next elements. So for element in array, if the element is greater than the first value, which is the root node, heap 0 at the heap, what we need to do is to heap q dot heap push pop. We can do this. So what it does, it pushes the element to the root and pops the previous root. So heap, which you have the heap here. You can see this code 360 has suggestions, which sometimes can help you a lot. Elements, yeah. Then we need to return the first element at the root node again, because if the elements greater than that value, if for example we are at 5, oh sorry, 3513 has already been popped out. Let me write an example here. For example, we have 5, yeah, something like this, and we'll be asked to return the second largest. So at first we'll start with 5 and 6 in the heap, or maybe third largest, 5, 6 and 8 in the heap, and then we'll take 9 is greater than the root, which will be 5, is greater than that one. So we'll pop 5 from the root node, and then we'll append 9 here. But since this is a heap, it will automatically align. So 6 will come here, 8 will come here at 6, 9 will be at the largest. So it will keep the process until at the end of the loop we are sure that the element at the root node is, yeah, as you have said. So return heap 0. But there are some cases where you find that the heap still is not equals to 4. So in those cases, for example, let me write a solution. Return heap 0 if the length of the heap is equals to 4. If it's not equals to 4, else just return the result, something like this. So now if I run the project, I'm expecting it to run line 5. What's wrong here? Invalid syntax. Okay. Oh sorry about this. It should be result. Copy it here. Problem of language switching. Okay, let me run it. Yeah, you can see it has passed all test cases, and if I click submit, yeah, you are better than 94.76%. I can do better than this, but yeah, the problem is solved. So that is it for today, guys. Thank you.